Pennsylvania Turnpike, once a dream of a few far-seeing men, is now a reality. Less than 2 years after construction was started, the 160-mile concrete limited way was open to traffic. Here are the men under whose leadership and direction Pennsylvania Turnpike took form. In the early days of the New World, the Alleghenies were a troublesome barrier to westward expansion. Pioneer trails and later the highways went up and down steep hills, through gaps, and along winding waterways. But the Pennsylvania Turnpike goes a way of its own. Men and machines have carved much of the route for this remarkable limited way through a mountain wilderness. With grade separations at every intersection, with 4 12-foot concrete lanes, 2 in each direction, opposing traffic is separated, with no grade exceeding 3%. With only a few curves of more than 4 degrees and skirting all towns, Pennsylvania Turnpike is a highway, or rather a limited way, engineered for rapid travel and for safety. Between industrial Pittsburgh and the seaboard, there is a heavy flow of passenger cars and trucks. The Turnpike is located and designed to carry much of this through travel. Beginning near Pittsburgh, the highway speeds through valleys, over deep fills, through tunnels and great cuts, and on through the more level country to US 11 near Carlisle, a few minutes from Harrisburg. Access to the Turnpike from Pittsburgh is gained over US 30, a multi-lane highway which here is of divided construction. Near Irwin is the west entrance to the Turnpike. The cars turning right are entering the Turnpike from a wide deceleration lane. Traffic entering and leaving the Turnpike does not interfere with busy US 30's traffic stream. The grade separation is a vital part of this time-saving traffic interchange. At the east end near Carlisle, this interchange transfers traffic to and from US 11. The Pennsylvania legislature has approved legislation for extending the Turnpike 110 miles to Philadelphia. No easy opponent, the Alleghenies. To avoid steep climbs, it was necessary to drill, blast, muck, and concrete line 7 tunnels, totaling 6½ miles. The longest tunnel is Sidling Hill, 6,782 feet. 6 tunnels are in the same locations as the tunnels started more than 50 years ago for a railroad that was never completed. We are now looking down from above a tunnel entrance. The tunnels have 1 traffic lane in each direction. Observe that traffic at the right emerging from the tunnel has 2 traffic lanes immediately available. In the background, note the traffic at the left is merging into 1 lane to enter the tunnel. Now let's continue our ride into one of the tunnels. A mighty air conditioning unit supplies each tunnel with cool, fresh air. The tunnels are lighted with a soft glow that's easy on the eyes. Actually, you do not need headlights. The tunnels have a clearance of 14 feet, 4 inches. The massive concrete entrances, with farm marks purposely left visible, blend in with the character of the country. Motorists look forward to the interesting interludes provided by these masterpieces of tunnel construction. Clear Ridge is the largest open cut on the Turnpike. Originally planned as a tunnel, the cut required the removal of 1,300,000 cubic yards of earth and stone. At this point near Everett, the Turnpike shoves its way through Alleykeepa Gap, whose footpaths served many an Indian and pioneer settler. To make room for the Turnpike, it was necessary to blast this spectacular side hill cut. In this cut, the Pennsylvania Turnpike Commission provided for the relocation of a local road, which now lies on the terrace above the turnpike. Requiring the removal of stupendous volumes of earth and stone, the turnpike was completed in record time because of the speedy, efficient equipment now available. Altogether, some 25 million cubic yards of earth and stone were removed, much of it placed in adjoining fields. But it takes men to operate and work with machines. Workers of all kinds numbered as many as 16,500. No mean task to juggle a rock as big as this one. The operator is having quite a time, but he made it. You can pass over a mile of the turnpike in a minute or less, likely thinking little about the great amount of labor or the many operations and machines required to produce a smooth-riding, dependable pavement. The first of the operations, preliminary to laying pavement, is preparing the subgrade. Various types of equipment were used on the turnpike, with the work always well in advance of the paving mixer. Most contractors used this handy machine, a side form grader. The rotating blades closely trim the earth to the prescribed grade line. Accuracy of construction marked the turnpike from beginning to end. Workers now come along to place the steel side forms. By carefully setting forms, contractors avoid costly delays later. On the turnpike, each contractor was required to have at least 700 lineal feet of forms set up in advance of paving operations. Pneumatic hammers were used by many contractors for driving pins which hold the forms in place, a great time saver where rock was encountered. This busy little machine tamps earth tightly. This gives a firm bed for the forms which support the spreading and finishing equipment during concreting. The bed for the pavement is shaped by a subgrader which speedily removes the excess earth. Such machines produce a true and firm subgrade. After the subgrade has been cut to grade and crown, it is thoroughly compacted by a heavy roller moving back and forth on the roadbed. When rolling is completed, the subgrade is nearly ready for paving. A final check to the subgrade is given by a scratch template. All high places are removed to assure the required slab thickness. Transverse expansion joints provided with load transfer devices were usually placed at intervals of 77 feet. A joint shield is placed over the expansion material for protection during construction. The shields are later removed, cleaned, and oiled for usage again. Cement, sand, crushed stone, or gravel were shipped to the batching plants by rail and by truck. It was indeed a tremendous task to coordinate quarry, rail, and truck operations to keep pace with the hungry mixers, particularly during one period when 38 of them were at work. Large stockpiles were necessary. Materials required to pave the 160 miles of 48-foot roadway would more than fill 300 trains of 100 cars each. All materials were tested periodically in field laboratories installed at each batching plant. The gradation and moisture content of the aggregates were determined carefully to find out their suitability and to adjust the concrete mixes so that the turnpike pavement would be of high uniform quality and strength throughout. By means of sieves, aggregate can be quickly separated by sizes. Then they are weighed on scales to determine the percentage of each size. By boom and bucket, the aggregates are transferred from the stockpiles to the towering batching bins. The aggregates first go into each compartment of the batch trucks, which carry 2 or 3 batches. Sand and 2 sizes of coarse aggregate are weighed separately and accurately for each batch. At another plant, the cement is carefully weighed and placed in a separate compartment for each batch. On contracts where 2 sizes of paving mixers were used, a batching plant for each mixer was set up. As many as 30 batch trucks were required on one paving contract. 2 standard paving mixers, working separately or in combination, were used. Here, a 34 cubic foot dual drum paver and a 27 cubic foot paver are placing a 24-foot slab. With few exceptions, paving operations were confined to placing a 12-foot lane at a time. On this job, a 34 cubic foot dual drum paver and a 27 cubic foot are paving a 12-foot width. Similar methods were used on 7 of the contracts. This is an unusual paving operation. One 34 cubic foot dual drum mixer is paving two 12-foot lanes at the same time. The boom and bucket place concrete on an outer lane and then swing over to place concrete on an inner lane. On this contract, one 34 cubic foot dual drum mixer is paving a 12-foot lane. Paving mixers operated singly on 13 of the projects. We will now follow through on this well-managed contract. Efficient organization and the use of equipment gave this outfit a production of about 240 lineal feet of 9-inch slab, 12 feet wide per hour. The batch of cement, sand, and stone, plus water, so easily handled by a large mixer like this, weighs about 3 tons. In a dual drum mixer, a batch of concrete is mixed in each drum for about half of the total mixing time. This speeds up production. Usually, water for mixing concrete, wetting subgrade, and for curing was hauled in tank trucks. Water was supplied the mixer by means of a pump mounted on the mixer or on a tank truck. Sprinkling lays dust and keeps the subgrade from absorbing water from the concrete too rapidly. The amount of mixing water was carefully controlled to ensure durable and uniform concrete. Free water in the mix was limited to 5 1/2 gallons per bag of cement. The normal cement content was 6 1/4 bags per cubic yard. Routine field tests were made to control the quality and strength of concrete during placement. Here, a slump test is in progress. These tests, made at frequent intervals, check the consistency and placeability of the concrete and the water content of the mix. These cylinders, made from concrete, as placed in the pavement, are broken at various ages to check on the compressive strength of the pavement. Beams are also molded from the pavement concrete. These are tested at various ages to determine the bending strength of the pavement and to help determine when the pavement may be safely open to traffic. Mechanical spreaders were used to distribute the mixed concrete between the forms. Here, a blade-type spreader is in use. Screw-type spreaders were used on many contracts. Note that the direction of the screw is reversed to throw concrete both ways. A vibrating puddler was used on several contracts along forms and along joints to consolidate the concrete at the face of the joints and around load transfer devices. On this contract, 2 transverse finishing machines were used. The first, equipped with only one screed, closely follows on the heels of the spreader. The second machine was equipped with 2 screeds, both of which are in operation as the machine moves forward. Extreme care was used in setting all screeds to their proper elevation. This machine passed over the pavement once, consolidating and shaping the concrete to its final contour. A mechanical longitudinal float removes all possible transverse ridges and produces a smooth riding pavement. All following finishing operations are largely to smooth out any remaining minor irregularities and to remove any excess water left on the surface. As the longitudinal float advances, the operator removes the metal joint shields, which have protected the expansion material. The next operation is to check and scrape the surface with rigid 10-foot straight edges. In finishing, over-manipulation was avoided, and the period from placement to finished surface was kept to a minimum. The outer edges of the pavement and the edges along transverse and longitudinal joints are rounded with an edging tool. In finishing the joints, one 2-man crew first removes the concrete from above the expansion joint material. Then, the joint is rough finished. A second 2-man crew quickly adds the finishing touches. To make sure that smooth riding qualities will be assured over the joint, the surface is checked with a straight edge. Almost any kind of surface texture can be permanently built into concrete. On the Turnpike, a burlap drag was used to give a texture which tires can grip to overcome skidding. Wet burlap mats were applied to the pavement surface as soon as it was finished to prevent rapid drying. These mats were used for the first 24 hours on all contracts. On this project, heavy burlap mats were left in place and kept wet for an additional 48 hours. On most contracts, the wet burlap mats were replaced at the end of 24 hours with heavy curing paper, which was left for another 48 hours. Before placing the paper, the concrete was thoroughly wetted. The paper covers were wide enough to extend over the edges of the slab. These were held tightly in place either by loose earth or stones. Forms were left in place 24 hours, and upon removal, they were cleaned and oiled for use again. After the forms were removed, earth was banked up against the exposed edges of the slab. When the steel plates used at the ends of transverse expansion joints were removed, any concrete in the joint space was promptly cleaned out. This is necessary to give unobstructed movement of the slab ends. Before opening the pavement to traffic, all joints are carefully sealed. Workers on this longitudinal joint are doing a remarkably careful job. Note the windbreak that keeps the sealing material from spattering. Carefulness was the watchword. Notice that this worker removes the spilled material. Sand is sprinkled along the freshly sealed joint to keep passing cars from picking up the sealing material before it stiffens. The pavement surface is again straight-edged after the curing period to check the thoroughness and accuracy of the construction operations. A final check on the quality, strength, and thickness of the concrete placed is done by test cores. One core is taken from each 4,000 square yards of pavement. The machine for taking these cores is an ingenious device. Round and broken steel balls, the size of small shot, form the cutting edge of this rapidly rotating cylinder. Here is the core, a husky piece of concrete, and it's a full 9 inches thick. And now with the grading of the wide shoulder, you've seen almost every one of the many operations on a typical turnpike construction contract. So let's shake off the construction dust and get a broad picture of this great highway, which doubtless will wield important influence on the country's future highway transportation. From start to finish, Pennsylvania Turnpike was engineered for the safety of the millions of drivers and passengers who will pass over it. Safety precautions did not stop with easy curves and grades and long sight distances. The work was carried on to include guardrails along all fills, light reflector buttons down the center and along both sides for night safety, and plainly visible caution signs. The pavement, too, was selected for dependable service and for safety. The surface texture produced by the burlap drag was designed to give motorists the utmost freedom from skidding. Access to the turnpike is by means of 11 traffic interchanges, including one at each end. Once on your way, you don't have to stop a single time. At every intersection with a highway or railroad, the turnpike is carried over or under by grade separations. Altogether, 121 concrete grade separations were built, nearly half of them rigid frame design. The rigid frame concrete structures are of simple architectural lines designed to fit modestly into Pennsylvania's charming landscape. All overpasses are high enough to give ample clearance for the largest vehicles. A test run has been made with military equipment, and the turnpike has been pronounced of extreme value to national defense. A variety of concrete structures carry the turnpike over intersecting roads. US 30 here passes under the turnpike near Bedford. This is part of the traffic interchange at the intersection of US 220. Barrel arch structures were used at a number of intersections with light traffic roads. Similar structures were placed over small streams. Near Clear Ridge Cut, a barrel arch bridge, 278 feet long, carried the turnpike over a local road. Twin barrel arches carry the turnpike over a stream near Everett. Built askew, the arches are 305 feet long. The largest concrete bridge on the turnpike is the multiple arch bridge with 7 spans, which carries the turnpike over a creek, a railroad, and a highway. The greatest span is 170 feet long. Pennsylvania Turnpike is a vivid testimonial to the planning, organizing, and construction abilities of the American engineer. The Pennsylvania Turnpike Commission completed financial arrangements October 10th, 1938. The first contract for 10 miles of grading and drainage was underway 17 days later. Carving a roadbed through this rugged, heavily forested land consumed far more time than the actual paving. Originally planned for a 3-year construction period, the turnpike was in use within 2 years after grading was started. So on the turnpike it was high-speed construction. 90% of the slab was laid in 5 months. Despite the remote location and excessive rainfall in April and May, 55 miles were built. In June, July, and August, 89 miles were completed. 144 miles of 4-lane pavement in 5 months. If speedy construction is wanted, road builders can give it. Today, Pennsylvania Turnpike, the dream of a few years ago, is at work, and road users are reaping the benefits that only limited ways can give. In addition to its built-in safety, Pennsylvania Turnpike reduces driving time through the mountains up to 5 hours. 2 miles of vertical climb are eliminated. Of vital military value, the highway also offers far-reaching peacetime benefits, bringing the Pittsburgh industrial area and the seaboard closer together. It also forms an important link for motor vehicle users farther east and west. Pennsylvania Turnpike is a reminder that the country's highway leaders, engineers, and road builders can master any problem of providing adequate arteries for traffic. Only a bold attack can give increasing motor traffic the kind of roads it demands.